Okay, so as we discussed in class, we're going to be looking at graphs that deal with vertical and horizontal shifts, and then we have some widening and some narrowing as well going on. All right, so if we look at this problem, this is on the bottom of page 3 in your packet, so you can turn to page 3 just in case there's anything that I say or write down that you think would help you. I would take notes in your packet. All right, so if we look at this, we see that this is a cubic. We can tell by the fact that we have something raised to the third power. And also we know that a cubic kind of does this little concave down thing here and then a concave up thing there. So this point here where there's a change in concavity, not that you need to know that for right now, but it's called a point of inflection. Now, so I see that this is definitely a cubic. And what I also notice is that, and let me just write this first. So a normal cubic would look like this, right? And that point of inflection would be at 0, 0. So we can definitely see that there's a shift because I look at it and I say, well, here's my point of inflection. So if I compare the two graphs, I went from 0, 0, and then I moved all the way to the left 2 and then down 3 to get from this point of inflection to this point of inflection, which clearly shows that there's a shift. So remember, when we're going to the left or to the right, that number is always going to be in parentheses with the x. But since I'm going to the left in this case, remember when we do horizontal shifts, we change the sign. So since I'm going to the left, I will actually put a +2 there instead of a -2, which is what a lot of kids normally think, so just be careful on that. So horizontal shifts are left and right. The number goes inside the parentheses, opposite sign of the shift. Okay, lastly, the number that's outside the parentheses is always a vertical shift. And in this case, we went down 3. So a vertical shift is exactly what we do. So in other words, if we go down 3, we write -3. The horizontal is the one where we do the opposite sign. Okay, so horizontal shift left, vertical shift down. All right, so let's look at the next one. So the next one is a square root. So I'm going to draw just a regular normal square root that we're used to seeing, and that's what a regular normal square root looks like, with the beginning of that square root at 0, 0. So once again, we can see that this graph doesn't start at 0 anymore, so there was definitely a shift. And in this case, we went 5 to the right. So remember, anytime we have a horizontal shift, it should be in parentheses, opposite sign. Well, this radical kind of acts like a parentheses. Okay, so whenever you have a radical, it will act as if we've got a parentheses there. And we went to the right 5. Remember, a horizontal shift means we go in the opposite direction. I'm sorry, we use the opposite sign. Okay, so in other words, we're going 5 to the right, so we actually write -5 instead. And then from here, we went down 5 units. Remember, vertical shifts are just exactly what we do. We went down 5, so we write -5. If we went up 5, we'd write +5. Okay, so there's your horizontal shift to the right, vertical shift down. Okay, so for the next one, turn the page and look at number 4. Page 4 rather, top left. Okay, so we have got a parabola or a quadratic, however you want to look at it. Now, I notice that my quadratic normally it would be like this, right? Like a smile. But I do know that I'm going to actually have a frown because of the negative in front of the x squared. Okay? So let me just draw that. So that's what the picture will look like because of the negative in front of the x squared. So remember what that represents when we have a number in front like that, right here. Okay, that represents a reflection in the x-axis, which that's what this says right here. Okay, so now if we look at either one of these vertices here, the vertex, the turning point, those are both at 0, 0. This one is not. So we had a shift down. And remember, a vertical shift is just represented by whatever amount we're going and in what direction we're going. So since I'm going down, I have a negative, and since we went down 3, I have -3. All right, so let's look at the next one. This is in the top right-hand corner of page 4. So that's an absolute value because it's a V. And normally my absolute value, its point is at 0, 0, and it points upward. So I notice that this thing has flipped, but look, I also notice that there's a negative there. So if there's a negative in front, just like on the last one, we flip over the x-axis or we reflect about the x-axis, which is what this says right here. Okay, again, normally my point there would be at 0, 0. And this is not, it's saying that it's at 2, 1. So that means, now the graph's not great, but just so you get it, I went to the right 2, and then I went up 1. So remember, a horizontal shift is always going to be written with the opposite sign of the direction that you went in. So if I'm going to the right 2, I actually have -2. And again, kind of like the square root. Normally we would have that -2 in parentheses, but the absolute value brackets kind of act as a parentheses here. So that's x -2. And then we went up 1, so vertical shift is always just going to be whatever we did. So if we went up, we would write +1. If we went down, we would write -1. So we have a horizontal shift to the right, 2 units, and a vertical shift up 1 unit. All right, now I'm on the bottom of page 4 on the left-hand side. This one is kind of important. I'd like you to take some notes. The first thing I want you to notice that I did was, I thought it was a little confusing here. So I just kind of highlighted this parabola in red. So if you want to do something, whether you've got a highlighter or you have a different color pen, it would be helpful because I want you to see that what I have here in red is the equation, the picture, the graph of the equation that they gave you up here at the top, okay? And the dotted one is, I'll tell you that in a second, okay? So maybe pause me for a minute and fix that in your notes. All right, so now I'm going to just start with, whoops, maybe I should put my pen on, that would be helpful, right? With a regular y equals x squared, because we know that this is a quadratic because we have a power of 2. Now, obviously this thing flipped upside down, so then if I was reflecting over the x-axis, my turning point would be at the origin still. So whether I'm here or I'm here, my turning point's at the origin. Now that negative accounts for the fact that we reflected over the x-axis, so we can talk about that right there. Then we also see, and it's stated right here, that our turning point is at -1, -1. Okay, so remember when we shift to the left 1, that's why we have a +1, and it's in parentheses, opposite sign, right? And then we did a vertical shift down 1. That's your vertical shift, always at the end outside the parentheses. So what I'm talking about right now is we reflected over the x-axis, we had a horizontal shift to the left 1 unit, and a vertical shift. That seems weird to me. All right, I think we have an error here, to tell you the truth, because that's not a vertical shift down 3 units. That's a vertical shift down 1 unit. And it makes sense because, look, we're down 1 here and down 1 here. Okay, so this is a little typo. So in your notes, please do me a favor and just change that 3 to a 1. Okay, so we vertically shifted down 1 unit. Okay, now this is the part, we're not going to spend a tremendous amount of time. I don't want you to freak out over it. We did discuss it, but a vertical narrowing by a factor of 2. So basically what's happening, and I know you're not allowed to use a calculator, but I just double checked in my calculator, I cheated, and I put this equation into my y1 without the -2. I just put a negative. And then in my y2, I put this in here. Okay, and I did get these 2 pictures, but what happened was this equation right here with the -2 is this red one, and do you see, if you compare it to the dotted lined parabola, it did narrow, okay, kind of squeezed in. So that's what a whole number will do to a graph. Okay, if you have a whole number in front of one of your graphs, it's going to squeeze it in and narrow it. Okay, whereas if you have a fraction here, it's actually going to do the opposite. It would take your equation and it would widen it. Okay, so that's why we call it a vertical narrowing by a factor of 2. Okay, this last one is on the bottom of page 4 on the right-hand side. You can see that I did the same thing as I did on the last one. So I just kind of highlighted, and you may want to do the same in your notes, the wider absolute value. So I'm just going to start by drawing a normal absolute value, the one that you're used to, which is just a V, and that change in direction is happening at 0, 0. Now I do see that I have a flip, so that would be a normal flip still with that point there at 0, 0. Okay, so I see that I have this, so once again, because I flipped, I know I have a reflection over the x-axis. And I also know that because if I look at the equation, I see that I've got a negative in front. Okay, now normally this point here would be at 0, 0, and we can see here 0, 0 that we went up, to the right one over 2. Well, to the right one means a horizontal shift, which means that number goes in parentheses, opposite sign. So reflection over the x-axis, horizontal shift to the right one. All right, then from here we went up 2 units. A vertical shift is outside the parentheses, and if we go up, we put +2. If we went down, we'd put -2. So that accounts for the vertical shift up 2 units. Now, if you notice, let's look at this red graph. Do you see it got a lot wider? It actually widened by a factor of 1/2. And this number in front here represents what factor it widened by. Okay, so it's an opposite thought. A lot of kids think, oh, a fraction, that's small, so it actually narrows it, and it's the opposite. Okay, so when we have a factor that's a fraction, it's actually a widening of that graph.